Welcome to Intro to Imaginary Numbers. Let's start off with a basic example. In order to solve this, you would subtract 1 from both sides. And then, to get rid of the exponent, you would take the square root. So you get x is equal to plus or minus the square root of -1. Except the only problem with that is we don't know what the square root of a negative number is. You can't do it, so usually we would say no solution. Well, mathematicians kept having this problem. They kept having to take the square root of negative numbers over and over again in their work. So they decided to actually make this a whole new set of numbers, and they decided to call it imaginary numbers. So the square root of -1, they said, was I. Lowercase I, not capital. And also we want to include that little tail at the bottom of the I, because if you write it without it, someone might mistake it for a 1. Or an L. So in order to make sure that it's definitely an I, include a little curve at the bottom of it. So imaginary numbers is just a new set of numbers that includes the square root of -1. You cannot see them on your graph, but they are there. And even though they're imaginary, I promise you, it actually has to do with a lot of mathematical applications in real life. If you want to simplify the square root of negative numbers, you're going to break it up into the positive and the negative. We know that the square root of 9 is 3, and that the square root of -1 is now I. Basically, it's the same exact thing how we would simplify radicals before, but if you see a negative, include an I in your answer. Also, if you need help simplifying radicals, check out my previous video on simplifying them. Square root of -18 breaks up into -9 and 2. I like to keep my negatives with the perfect square. We know that the square root of 9 is 3. Because it's a -9, include an I. You can't take the square root of 2. From there, 5 times 3 is 15. I, radical 2. We always write the coefficient first, then the I, and then the radical. You can't break up the square root of 6 into a perfect square and something else. So because it's a -6, the only thing you could do is pull out the negative by making it an I and writing the square root of 6 next to it, because this is technically the square root of -1 times the square root of 6. Again, anytime you see a negative under a radical, make it a positive, put an I out front. If you want to solve a quadratic equation with complex solutions, so imaginary numbers and complex numbers are pretty much the same exact thing. If they tell you to find the roots in simplest a+bi form, that means you're going to have an imaginary answer. And if you don't get I in your answer, you know you went wrong. You can't do this by factoring. You have to use the quadratic formula, which, if you don't remember, is x equals -b plus or minus the square root of b squared minus 4ac all over 2a, and that is on your reference sheet. Your a value is 1, b is -6, and c is equal to 13. So we're going to plug that in because it's already set equal to 0 for us. And you get x is equal to -6 plus or minus the square root of -6. Make sure you're using parentheses for these negatives. A is 1 and c is 13. All over 2 times 1. You're going to take what's underneath the radical and put that in your calculator all at once. That way we get 6 plus or minus the square root of -16 over 2. The square root of 16 is 4. Because it's a -16, you include an I. All of these numbers have a 2 in common, so divide all of them by 2. And you get 3 plus or minus 2i. Please do not write the 1 underneath it. Anything divided by 1 is itself. So there you have it. And please make sure that you write the 2i last, right? A plus bi form, the I comes last. Now, what do you think the graph will look like and why? Told you before that you can't see imaginary numbers or imaginary solutions on your xy axis. So because we have two imaginary roots, right? Our first imaginary root is x equals 3 plus 2i. The second imaginary root is x equals 3 minus 2i. Well, imaginary roots means no x intercepts. So this is a quadratic equation, right? You know you're going to have a parabola, and you know that it will not touch the x-axis. And as you can see, it doesn't. So that's how you know you have your imaginary roots. That's all for this video.